Have you ever looked up at the night sky and wondered where it all came from? The Big Bang Theory is our best explanation for the origin of the universe. It tells the story of how everything we see around us, from the tiniest particles to the largest galaxies, emerged from a single point billions of years ago. This point wasn't an explosion in the traditional sense, but rather a rapid expansion of space itself. Imagine a tiny, incredibly hot and dense speck, smaller than an atom, containing all the energy and matter that would eventually become the universe. Then, about 13.8 billion years ago, this speck began to expand, an event we now call the Big Bang. The Big Bang Theory is often misunderstood. It's tempting to picture it as a giant explosion, like a firework going off in the vast emptiness of space. However, this is not an accurate representation. The Big Bang wasn't an explosion space. It was the expansion space itself. It's as if you drew dots on a balloon and then inflated it. The dots wouldn't be exploding outward from a central point, but rather moving apart as the balloon itself grew larger. This expansion, which began 13.8 billion years ago, continues to this day. The universe is still growing, with galaxies moving further apart from each other over time. This continuous expansion is a key piece of evidence supporting the Big Bang Theory. The Big Bang Theory also explains the composition of the universe. In the intense heat of the early universe, the simplest elements, hydrogen and helium, were forged. These elements still make up the vast majority of the observable universe, providing further support for the Big Bang. The Big Bang happened billions of years ago, leaving clues that tell the story of our universe's birth. One compelling clue is the cosmic microwave background, CMB radiation. This faint afterglow of the Big Bang permeates all of space. Imagine the heat radiating from a campfire long after the flames have died down. The CMB is like the cooled-down heat from the Big Bang. Another crucial clue is the expansion of the universe itself. In the 1920s, Edwin Hubble discovered galaxies are moving away from us. This observation, known as Hubble's law, showed the universe is expanding. The Big Bang Theory doesn't just tell us that the universe began with a rapid expansion, it also provides a framework for understanding what happened during those first fleeting moments. In the first fraction of a second after the Big Bang, the universe was an incredibly hot and dense sea of energy. One of the earliest epochs, known as the Planck epoch, lasted for an unimaginably short period, less than 10 to the power of -43 seconds. Following the Planck epoch was the inflationary epoch. During this period, the universe underwent a rapid and exponential expansion, growing from a size smaller than an atom to something closer to a grapefruit in a tiny fraction of a second. This rapid expansion helps to explain why the universe appears so uniform on a large scale. As the universe continued to expand and cool, energy began to convert into matter and antimatter, which are particles with opposite charges. As the universe expanded and cooled, protons and neutrons, the building blocks of atoms, began to form. This process, known as Big Bang nucleosynthesis, occurred within the first few minutes. The universe was still too hot for atoms to form. Protons and neutrons collided, creating hydrogen and helium nuclei. About 380,000 years later, electrons were captured by atomic nuclei, forming the first atoms. This event, known as recombination, marked a significant turning point. The universe became transparent, allowing light to travel freely. The formation of atoms paved the way for stars and galaxies. The Big Bang Theory is a complex and often counterintuitive idea, and as such, it's surrounded by a number of misconceptions. One of the most common is that the Big Bang was an explosion in space, with matter flying outward from a central point. However, as we've discussed, the Big Bang wasn't an explosion in the traditional sense. It was the expansion of space itself, with all points in space moving away from each other. Imagine a loaf of raisin bread dough rising in the oven. The raisins, representing galaxies, all move apart from each other as the dough, representing space, expands. There is no single center of the expansion. It's happening everywhere at once. Another misconception is that the Big Bang Theory explains the origin of everything. While the Big Bang Theory describes the origin of the universe as we know it, it doesn't explain what existed before the Big Bang, or what caused it. These are still open questions in cosmology. One of the most profound implications of the Big Bang Theory is that the universe is not static, but rather dynamic and evolving. The discovery that the universe is expanding has fundamentally changed our understanding of our place in the cosmos. But what does it mean for the universe to be expanding? As we've discussed, it doesn't mean that galaxies are flying through space away from each other. Instead, it's the fabric of space itself that is stretching, carrying the galaxies along with it. Imagine dots drawn on a balloon. As you inflate the balloon, the dots don't move across the surface, they move apart from each other as the balloon itself expands. This is analogous to the expansion of the universe. The expansion of the universe has profound implications for its future. If the expansion continues indefinitely, as current evidence suggests it will, the universe will continue to cool and become increasingly diffuse. Galaxies will move further and further apart, and eventually the night sky will become dark and empty. The Big Bang Theory, while incredibly successful in explaining a wide range of observations, is not the final word on the origin and evolution of the universe. It leaves us with many unanswered questions, each one a tantalizing mystery waiting to be solved. What existed before the Big Bang? What caused the initial expansion? What is the nature of dark energy, and how will it shape the future of the universe? These are just a few of the profound questions that continue to drive cosmological research. The quest to understand the universe is a journey of discovery, a continuous process of observation, experimentation, and refinement of our theories. The Big Bang Theory represents a major milestone in this journey, providing a framework for understanding the vastness of space and time. As we continue to explore the cosmos with ever more powerful telescopes and sophisticated instruments, we can expect to make new discoveries that will challenge our current understanding and lead to even more profound insights into the nature of the universe and our place within it.